Send the Desmos link. Here you go. So if you're just tuning in to the recording, which I just started the recording, y'all. Right now what we're doing is we're answering this welcome question. And what we're doing is we're looking at the difference between the unit circle and our Ferris wheel example. Kind of how are they different? What's different about their size? What's different about their period, right? How long it takes to do a rotation and so on. All right, I see that most people have joined us in here. Okay, cool. Everyone's joined us now. By the way, if you're watching this as a recording, there is, as you can see, this Desmos classwork, which is attached to the slides. So today is going to be about us going between these slides, and kind of the slides will be where a lot of our learning happens and our instruction, and then the Desmos is where we will be practicing some of it. Cool. I see a lot of people have already answered the welcome question. That's great. Please try to get your thoughts down in the next minute. Alrighty. If you're still writing down ideas for that welcome question, guys, feel free to go ahead. But what I'm going to do is I'm going to look at some of the thoughts some of our classmates have had here, and I'm going to start from the bottom. So, so one thing that is observed, Fernando says the unit circle starts at 0, the wheel starts at 3π/2. That's a good observation. That's the starting position, guys. So if you look at our two models, remember the Ferris wheel, the people started at the bottom. They started at the minimum here, whereas the unit circle, we view it as starting on the right side at the midline. So that's a good thing to observe. Let's see. The Ferris wheel is 10 meters above ground and takes 30 minutes for the Ferris wheel to turn all the way around, right? So that's what Lori said. And so what she's observing is that our minimum, right, where the minimum height of that Ferris wheel is different from how the unit circle is, right? The unit circle is above and below a midline of 0. Notice how the middle of the unit circle is at y = 0. A lot of what we are going to be thinking about today, guys, is in terms of heights and y values, just because it's sort of a natural starting point for us, okay? So you'll notice that a lot of the time we're talking about kind of the y coordinates because that was sine, and we're kind of still focused on sine right now. In the future, we can be looking at the x coordinates actually, and then that would be the cosine, which is kind of something interesting. What else do we got? The unit circle seems larger than the Ferris wheel model, only because of my picture. I put this picture I put is big, but if you think about it, right, the unit circle has a radius of 1 unit. That's why it's called the unit circle, right? And then the radius of the Ferris wheel, people calculated in our mastery assessment to be 79 meters. So they do have different amplitudes, right? Anything else people are noticing to point out? Triangles on the Ferris wheel are evenly sized, while on the unit circle they're sized differently. Yeah, that's an interesting kind of thing to notice because of the way the fractions are cut. These aren't actually all evenly spaced because really it's like it goes by 30s to go to 30, 60, 90, 120, 150. But then we cut in the middle because we also cared about 45, 90, 135, 180. Ferris wheel starts at the bottom, unit circle starts on the right, excellent. Ferris wheel much bigger, cool. It seems like we kind of got a bit of the idea here. Ooh, Victoria points out that the height for the Ferris wheel is a maximum of 168 and a minimum of 10, and that it has a 30-minute period. So those were good things to observe in terms of like looking at the difference in size and timing for the unit circle and the Ferris wheel. The Ferris wheel doesn't have a negative angle. Ooh, technically it could have a negative angle. Essentially, guys, notice the Ferris wheel is rotating counterclockwise. So if I just think about it backward, right, I go clockwise. If I think backwards, that is a negative angle. And a lot of times what that would be looking like, guys, is it's sort of like looking back in time. So it's like if I look at it going backward, I'm looking at it like, oh, well, what about instead of thinking about 15 minutes, instead of thinking about it taking 15 minutes to get from the minimum to the maximum, I could, once I'm at the maximum, I could say, oh, well, 15 minutes ago, I was at the minimum, right? So it's kind of like thinking about like, oh, time in the past versus time in the future. And that's kind of where the positives and the negatives would be. Whereas the present time would be time 0. Cool. So guys, we're gonna move ourselves on along from this question. So looking at our agenda, I'm gonna just go quickly through this. Our outcomes for today. It says, let's randomly determine. I'm gonna randomly determine myself. So today, what we're gonna learn, guys, is to identify 4 things: amplitude, period, which we've already talked about so far, and then two new ones: midline and phase shift. And this is all for periodic models. So the mastery assessment that I had you guys doing this last weekend for week 3 was all about finding amplitude and period of a model. And today we're gonna go over it briefly. We'll discuss it, and I'm gonna solve it with y'all. And then what we're gonna do is we're gonna expand our ideas of this to include what we call the midline and phase shift. All right. So let's go ahead and get it, y'all. To start things off, going over the mastery assessment. So guys, I would like people to open up their mastery assessment on Google Classroom. So here is the link to Google Classroom in case that makes it easier for you. So in the chat, I've posted the link. Otherwise, you guys can just go to classroom.google.com and find your week 3 mastery assessment, please. I want people to pull that up so that you guys can see, because I've now graded them, so you guys can see how you did. And then while we're looking at that, I just wanted to let you guys know, if you got less than a 3 out of 3 on the mastery assessment, then you are welcome to complete a mastery reassessment this week. Okay, so there will be essentially a retake. It's not the same, it's not gonna be the same exact quiz, but it'll be similar ideas. Okay, and there'll be a reassessment that you can take this week. And if you have any sort of conflict where you won't be able to do it this week, but maybe, but you still want to do it, then just talk to me through either email or on Google Classroom or on Discord. Just message me and like, let me know, okay? So that way I'm aware. So if you're gonna have any conflict with being able to do that reassessment this week, let me know, please. I would encourage anyone who didn't get a 3 out of 3 to do the reassessment. I think that a lot of what I'm trying to do, guys, with these mastery assessments, by the way, a lot of, you'll notice by now, I hope, the pattern is that I'm essentially, each of these mastery assessment is going to take what we were learning previously and essentially kind of put it and have it direct us to the context of what we're gonna learn the next week, right? So it's kind of like making the connection from week to week. That's what the mastery assessment is about. So like the first week's mastery assessment was about us going from the special triangles and creating the unit circle, right? It was about like using the special triangles to make the first quadrant of the unit circle. That's what it was. And this one was about us understanding amplitude and period in a model. So let's go ahead and look at that guy. I'm gonna pull up my whiteboard for y'all because I think that that'll be a better way for us to talk about this. So new share. So you guys can see my whiteboard now, right? So I want to go over this real briefly with you guys. So first of all, it asks us what is the period, right? It asks us for the period of this guy. I'm gonna make this a little bit bigger for us. So it asks us for the period first. Now remember, guys, period we said was the amount of time it took to do a full revolution or complete one cycle. So you can see here that we said that the high roller took 15 minutes to go from the minimum to the maximum, right? So one full revolution would then be double that. It would be 30 minutes. I think a lot of people got that one. Pretty much, yeah, most people will realize that. By the way, guys, while we're going over this, feel free to ask questions in the chat on Zoom if you have any. So that's the period of it. So it takes about 30 minutes to go all the way around, right? Now it asks us, what is the amplitude of the high roller? Okay, so amplitude, guys, if you remember, was essentially when I was looking at my sine function, for example, it was how far above and below does it go, right? So it was like, how far is it from how far above and, oops. It was like, how far up does it go? Essentially, this was the amplitude, right? So people found this a number of different ways. One way that I saw most people do was they said, okay, well, if I know the diameter, right? If I can find the diameter of this, then I could find the radius, which is the amplitude, remember the radius of the unit circle was the amplitude. Similarly, the radius of this guy would be the amplitude by just dividing by 2. So they said, okay, well, 168 minus 10 is 158. So that's the diameter. So then the radius would be half that, which would be 79 meters. Remember, guys, when we're working in a real world context, you want to include your units. So this was 79 meters. That's kind of hard to see, huh? Maybe a different color? Yeah, it's still hard. Okay. 79 meters. Cool. So that was the first 2 problems. And those were, I think, a little bit more straightforward than the third one. But the third one was a problem that I liked a lot because I thought it kind of takes these ideas, and especially the idea of like what is amplitude, and it really asks us to think of, and also the idea of period, and kind of asks us to combine the 2 of them to think about this problem in a context of what is our height at 22.5 minutes, right? So what I want you guys to notice first of all, remember at 15 minutes, I'm at a maximum, right? I'm at the maximum at 15 minutes. So then at 22.5 minutes, that is 22.5 minus 15 would be 7.5 minutes later, right? So where would I be in the circle at 22.5 minutes? Well, I'd have gone halfway around and then another quarter, right? I'd be here. Do you see why I'd be there?
Yes.
Yeah. So what was that, Millie?
The whole body is 15 and the 15 is half of 7.5, so it's go another half.
Yeah. So half of the 15 minutes was the 7.5. So it's like, okay, it's gone 3/4. Essentially, guys, 22.5 is 3/4 of 30. In fact, if I do, if I do 22.5 divided by 30, I would get 0.75. So you would see like, okay, it is 3/4 of the way around the circle, right? So all I need to do is figure out what's the midline. And I actually had a lot of people realize this, and then they calculate the midline incorrectly. Okay, so there's a couple ways that I saw people calculate the midline that worked. There was two main ways, right? So first of all, guys, if I know how high the maximum is, and I know how big a radius is, then I could just subtract them, right? So I could say 168 the maximum minus the radius of 79, aka the amplitude, right? So the maximum minus the amplitude would be equal to the midline, which was 89 meters. So this was max minus amp. You guys see that? So that was one way. That was one way people solved it. Another way people found the midline was they took an average of the maximum and minimum. They said, okay, if I do max plus min and I divide by 2, that'll give me the middle because it's the average, right? And if you did that, you'd get 168 plus 10 is 178 divided by 2, which would be 89 again. So that was the mastery assessment for this week. At this point in time, guys, if anyone has questions, please post them in the chat or unmute and ask away. If you want to, yeah, Millie, what's up?
So when you told me I have a mistake on 3 and I changed it and I got the answer 89, but I just plus 10, 79 plus 10.
Uh-huh.
And I resubmit. Can I get 3 out of 3?
So on this particular one, so yeah, so if I hear you correctly, you're basically saying, okay, I saw the mistake that I had made on number 3 and I fixed it. Can I resubmit for the reassessment? I would actually like people, there was a number of people who are in your situation, Millie, and I would like those people to actually complete the reassessment. It'll be it'll cover similar ideas, but it's something where I do want to kind of see people actually try it again, rather than just take what I just now talked about. Because not to say that that's what you're doing, Millie, but like that is what you could do.
No, I changed it yesterday.
Okay, but yes, I still would like people to do that. Okay. Cool. And I'll post on Google Classroom with that reassessment. It shouldn't be very long. Okay, cool. So that was the week 3 mastery assessment, right? So now I'm going to take us back. I'm going to take us back to our slides for today. So what I wanted to do, guys, was kind of break down these ideas of amplitude and period, and then we're going to introduce some new ideas in a similar fashion. All right. So first of all, let's look at for amplitude and period. So far, we've explored the differences of amplitude and period for the unit circle in our Ferris wheel model. That's what we literally were doing in that mastery assessment, right, guys? So we observe that the Ferris wheel is larger than the unit circle, and therefore it must have a larger amplitude, right? And so additionally, the Ferris wheel takes 30 minutes to go around, while the unit circle takes 2 pi radians. So therefore they have different periods. So these are just observations we can make based on looking at the two models, right, guys? So what I wanted to do was let's take note of those differences, and I'd like people to please copy this into their notes. Take a moment, draw a table that like the one that I have here, and what we're going to do is throughout today we're going to add to this table the differences in the features of the unit circle versus our Ferris wheel here. I would suggest at least having a drawing of the Ferris wheel in mind, since you guys already have the unit circle supposedly in your notes, right? You guys should have the unit circle in your notes by now. But so I'd like to give people a minute to just kind of copy down this table. Am I going to share these slides with us later? Yeah, actually, in fact, I should share them with you guys right now. There you go. But I will also add these slides to the, what I'm going to do is for today's like a lesson assignment, I'll have like the link to the recording of this video. I'll have the link to these slides, and I'll have the link to the Desmos. All right. Based on our timing already, guys, I kind of was low-key expecting this. This may end up being a lesson that we have to continue next time, in terms of like completing all this stuff. I think I'm not going to assign this as homework. So I just want to see where we get today, and then we'll have to finish it, I think, on Friday. Or maybe we'll finish it with the async, kind of going over it. We'll see where we get. All right, guys. Well, if you haven't already finished copying this down, you'll get more chances to see this table later. Okay. So while we're in our notes, guys, I wanted us to have formal notes. Yes, Lanisha, I will post the reassessment today. I was hoping that we would have some formal notes about these ideas. Now, guys, I really want to encourage y'all, when in terms of this trig modeling stuff, keep notes at the ready. There's a lot of ideas that are kind of small, like definition things, like amplitude and period, and it's going to be much easier to just keep things written down that you can review rather than trying to memorize it all from today, right? So first of all, guys, amplitude is the height from the midline to the maximum or minimum of a periodic function, right? And we can always calculate the amplitude of a periodic function by doing the maximum minus the minimum divided by 2. That's what we did in our mastery assessment there. We took the max value, we took the minimum value, and we subtracted them to get the diameter, and then we divided it by 2 to find the radius. So I'd like people to please make sure that you have this written down today in your notes. All right, so now period. What is period? So period is the length from one peak to the next, or from really any point to the next matching point. So you can measure the period of a periodic function in many different ways. But it's going to be equal to the length of one full cycle, right? One full revolution, one full repetition, right? And I actually have a diagram that I want to show you guys to show you how there's multiple ways we can find the period. So here is the graph of sine. This is just the sine function. You can see its period is 2 pi, right? Because see how from 0 to 2 pi is how long it takes for it to do one full loop up, one full trough down, and then it starts repeating itself. So you guys see how from essentially from one point until the next matching point, right? See, I'm at the midline going up, and then I'm at the midline going up again. So I've repeated. That's one period. Another way you can calculate the period, guys, is from maximum to maximum. So check this out. If I look at the distance from one maximum to the next maximum, that would be one full period. And you can even count it. Look, I'm at pi over 2, and then it goes to 5 pi over 2. That's a length of 1/2, 2/2, 3/2, 4/2 pi. So you can see that it's the same measurement no matter which way I'm measuring it. Anyone have any ideas of one other way that we could find the period of this? What's another way we might be able to find the period of this, other than from maximum to maximum or from that middle to the middle?
Now you can minimum to minimum.
Exactly. If I can go from maximum to maximum, then I should respectively be able to go from minimum to minimum. So you can see there when this thing goes away, you see there the first minimum is at negative pi over 2, and the second minimum is at 3 pi over 2. That's a distance of 2 pi, so I could actually use that as well to figure out period. Right, guys? And so we can actually use this idea in many contexts. It doesn't always have to be looking at a graph, right? For example, in our classwork, which we're gonna move forward to slide 2. So if you guys go to the Desmos slide 2, check it out. What I've given us is I've given us 2 different models of periodic behavior. And I'm asking us to determine amplitude and period for each of the models. Okay, guys. Now, what you'll notice in the classworks, what I've done here, y'all, you could find the amplitude and period based on the description, but I've also included a graph of each of the models just because I think that while we're still developing our understanding, it's gonna be useful to have kind of both. Okay, guys. So right now, what I would like us to do is I'll put this slide back up so that people can keep taking notes if they need to, but I'd like everyone to please be on slide 2 of the Desmos activity, right? Here, oops, that's not what I wanted to do. So everyone's on slide 2 of the Desmos activity. And I'd like you guys to go ahead and give that a shot. Try out figuring out what the amplitude and period of the tides at Port Ugal are. And then similarly with this example of a heart pumping blood. All right. I'm gonna give us about 5 minutes and then we'll check in on how people are doing with that. Remember to refer to your notes, y'all, right? Refer to the notes that we've been taking. And honestly, just give this your best effort, guys. Right now, what we're doing is we're practicing. This is not the assessment, all right? If you're ever given the maximum and minimum of something, then calculating the amplitude is easy because we have a formula for it. Remember that, y'all. Awesome. I see Rachel found the amplitude very nicely. Ooh, I see Mila found the period of the first one very nicely. Well done. Same with Christine. Excellent. I see some people showing their work that they did to calculate these things. That's awesome to see, guys. I might suggest trying out using the type math button, right? Remember that square root button that you can use so that you can type the math and make it look cleaner. Especially if you're doing fractions and stuff, it can be helpful. The word problem looks more confusing than the graph. That's why the graph is there, to help out. I'm aware that connecting from a word, from like a situation to the concepts is harder than connecting the graph to the concepts, right? However, I think that it's important for us to practice being able to identify these kinds of features from a context, because I think that that's like where the real math lays, right? A lot of times, like the true math, right, like the problem solving, right, the reasoning, that stuff is all about kind of like, can I look at a context and determine the information, which then once we have that information, we, you know, it's easy money for us to calculate things. This is all about us looking at and deriving models. Speaking of which, go ahead and try to wrap up your thoughts on whichever one you're looking at currently, guys, because we're gonna go ahead and we're gonna have someone share their solution for the first one. All right. I'd actually really like if ooh, who should I have? Okay. I think we're gonna have April help us out. April, can you help us out a little bit? Bruh, she says. Yes. Thank you, April. I appreciate you. So guys, we're gonna have April help us out with like looking at how does this, how do we solve this first one, right? So, oh, what am I doing? There we go. Can you guys see that? So April, are you there? So for the first one, for amplitude and period, could you tell us how you solve this?
For amplitude, I use like the formula. So I did maximum minus minimum and then divide that by 2. So 4 minus -2 is 6, and then 6 divided by 2 is 3. So the amplitude is 3 meters.
Okay, so we've got the maximum minus the minimum over 2. You said the maximum was 4. 4, and then the minimum was -2. So 4 minus -2 over 2. And subtracting a negative, you add, so you got 6 over 2, which was 3, you said?
Yeah.
3 meters. Exactly. So guys, that's how you can calculate amplitude. And in fact, if you look at the graph, right, see how here it looks like it seems like this is the middle, right here at like 1. And look, it's going up 3, and it's going down 1, 2, 3 as well. So you can kind of see the amplitude in the graph. Okay, then how did you find period, April?
For this one, I looked at the graph and I saw the maximum at 3 and then another one at 15. So 15 minus 3 is 12. So it was 12 hours.
So from maximum to maximum, you said was 15 minus 3, which equals 12 hours. Cool. Thank you very much, April. That's a very cool way to do it. Did anyone find the period differently? Did anyone find the period differently than this?
Yeah.
Yeah, Millie, how did you find period?
I use 9 minus 3 equals 6, and 6 times 2 equals 12.
You said what? That
9 minus 3 is
9
9
minus
a.m.
3
to 3 a.m.
Ooh, yeah, so you said that period is equal to twice the distance from a maximum to a minimum.
Yeah.
So this uses kind of the way that we did period in the mastery assessment, guys, where we knew that from the minimum to the maximum was 15. So then we doubled it to get the full revolution. She's doing the same thing. She said from the maximum at 3 a.m. to the minimum at 9 a.m. was 6 hours. So if I double that, I should get the full rotation, which is 12 hours. Awesome. Thank you very much. I also saw someone, I think, calculated it from minimum to minimum. They said, oh, 9 to 21 was a difference of 12 hours as well. Cool. Thank you very much, guys. That was finding amplitude and period. I really think that this one here is a really important idea. So I want to really highlight this for you guys. The distance from the maximum to the minimum, or from the minimum to the maximum, is always going to be half of the period, guys, right? Because minimum to maximum is always half the circle. Does that make sense? What about number 2? Did anyone find the amplitude and period for number 2?
I did.
Yeah, Mila, can you help us out?
Okay, so for the amplitude, I got 70 because if you look on the graph, the highest point is 140 and the lowest point is 0. And so 140 minus 0 is just 140. And so then you divide it by 2 and you get 70.
Ooh,
And then
true.
period, I got 1 because like if you just look at the graph, the highest points that are at 140, they're only 1 apart.
Okay, cool. Yeah, so looking at the graph from maximum to maximum, we see that it is 1. Another way you could have found, thank you very much, Mila, by the way, that's awesome.
Yeah.
Another way you could have found the period, by the way, guys, if you notice, it says that the heart beats 60 times per minute. There's 60 seconds in a minute, right? So if it's happening 60 times per minute, then it's happening once per second, right? That's kind of like, this is an idea, like knowing how many times it happens per minute or like per second or whatever, right? Like if I know how many times it happens per something, that's a measurement called frequency, right? So something happened, if like, for example, we talk about beats per minute with songs. If a song has 20 BPM, that means that the beat is happening 120 times per minute, right? So that's a frequency, and frequency and period are very similarly related, but they're inversely related. Would we put milliliters for 70? That's a good point. Yes, if our unit is milliliters, we should be putting that, and if our unit is seconds, we should put that there as well. I want to point out something, guys. I made a big mistake here in my graph. So some people probably got amplitude 70 in the same way that Mila did from looking at the graph. But if you used the word problem, actually you would get an amplitude of 35. And this is something that I'm just now noticing. My bad. Basically, guys, it said that it pushes out half of its volume and then pulls back in the same amount. So really, the minimum shouldn't be 0 because actually the heart doesn't reach 0 blood in it. That was my bad when I made this graph. So damn, that kind of changes some of the things in this. Whoops. So if you said 70 or if you said 35, right, based on like the way that you did it, I would take either one of these because that's my bad. That's my mistake. So why would it be 35? Because if it's only losing 70 at the end, then 70 would be the minimum. So really, this function here should be going up and down between 140 and 70. That's my bad. So to reiterate, Mila did an awesome job calculating amplitude and period from the graph. And I know I saw some people getting amplitude 35, and I assume you did it from this, and that's awesome too. Cool. So that's kind of like a little bit of practice with us figuring out amplitude and period from a model. Okay, guys. I think that we have enough time to talk about midline, but I think that we will not reach phase shifts today. And that's fine. I think that I can actually, phase shifts might be better for us to talk about on Friday anyways. All right. So let's say that our focus for today, we're skipping phase shift, but we're still including midline. And I think that that's what our asynchronous assignment is going to be all about anyways next week, or for this week. We'll talk about amplitude, period, midline. So let's talk about midline. In exploration, guys. So could I have everyone please change their focus from the Desmos back to our Zoom screen share? So one of the major differences between the unit circle and the Ferris wheel is in their positioning. Notice, guys, that the unit circle is centered around around the origin, right? So for example, the middle is at y equals 0, whereas our Ferris wheel is lifted, right? The Ferris wheel has a raised central positioning. Now that central positioning there is going to be known as the midline. And that was what we calculated, that midline, right? That middle is actually what we calculated in number 3 on that mastery assessment, right? So see, notice, remember guys, we said that this was the midline here. Okay. So midline is going to be a way for us to look at essentially things like amplitude and the period and kind of looking at our positioning of our function, right? So, so that's what the midline is. So now let's take some notes about, okay, well then how do we find midline? So definition first, a midline of a sinusoidal function. Sinusoidal just means it's any periodic function that can be modeled with sine or cosine. Is the horizontal center line about which the function oscillates above and below. So it's the middle line, the function is going up and below, above and below. The midline is parallel to the x-axis, right? That's why it's horizontal. And it's located halfway between the maximum and minimum value. This means that the midline is actually just the average of the max and min. So we can always calculate midline, guys, by doing max plus min divided by 2. Okay. So for example, in our Ferris wheel here, we had maximum 168, minimum of 10. So the midline was 89 because you added those and divided by 2. And then alternatively, guys, we pointed this out during when we were talking about the mastery assessment, but alternatively, midline could be found by looking, if you know the amplitude, right? If you know how much it's varying, then you could just look at the maximum minus the amplitude, right? For example, 168 minus our amplitude of 79 gives us that midline of 89. Or you could look at the minimum plus the amplitude. So there's lots of ways in which you can find these various pieces of information, guys. And once you find kind of one thing, like once you find midline or once you find amplitude, finding the other one becomes easier, right? Because similarly, if I know that midline is maximum minus the amplitude, then I could know that like the amplitude is the maximum minus the midline, right? So it's like once you know one of them, you can easily find the other one. I'm gonna leave this up here a little bit longer for people to go ahead and take note of. And then we'll go to the next slide. Okay. So looking back at the tracking the differences thing that we had, I've added now midline to it. And notice the unit circle's midline is at 0, right? Y equals 0. Whereas the Ferris wheel had a midline at 89 meters. All right. So what I'm going to do is I want to give people a chance to try out on our classwork practicing finding midline. So if you guys go to the Desmos, back to the Desmos, you can see that on slide 3 now, right? If you go back to the Desmos, you should see on slide 3, what it's asking us for is to determine the midline for each of the same, and it's the same examples, okay, guys? Now, what I would like people to try to do, try to find the midline based on the information in the model example, in the written model. See if you can find the midline that way before you go to the graph. All right, guys. I'm gonna leave the slide that I'm sharing on the notes for midline in case anyone needs to still copy that. But otherwise, guys, try to find those midlines, and we'll talk about that before we leave today. So I see most of us have gotten on to slide 3 for that Desmos activity, but I think there's still a few people who need to swap their focus of their screen when you get a chance. Remember guys, midline is not the same as amplitude. Peep the formula. Nice job finding the midline on the second one, Christine. That's like that's the midline that it should have been, but my graph does not show. So what I was saying, by the way, guys, for the second model, if you ignore the graph for now and you just look at the model, it says that essentially the maximum volume is 140 milliliter, and then it pushes out half of that, so the minimum is 70. So in the model, right, like in the written model, my maximum should be 140 and my minimum should be 70 actually. So this is a mistake that Mr. Hoba made with the graph. Might be on that. I see Lanisha went ahead to the slide 4. That one's not going to make any sense to us until we talk about phase shifts. Maybe it'll make sense. Maybe you can figure out what phase shift means based on it. If you haven't already found the midline, by the way, guys, on slide 3, please continue to give it a shot. Remember, keep in mind the formula that we have for midline, maximum plus minimum divided by 2. Give it a shot on that first one. You guys got this. We'll debrief it real quick in about 2 minutes before class ends. Yeah, Liz, I see you put a question mark on your second answer, but it's correct. Ooh. Low Celine, you're close with that. You have the right fraction written, but you got to evaluate it differently. Double check your math on that. I think you subtracted 2 instead of dividing 2. Alrighty, let's go ahead and have us debrief this, y'all. So guys, please go ahead and just pause what you're working on. Go ahead and refocus on the Zoom that I'm sharing my screen with. Y'all should see your classmates' answers. You can see a lot of people got 1 for the midline. And now essentially, guys, I mean, so if you see, notice our maximum height was 4. Our minimum was -2, right? And so if I do max plus minimum, that's 4 plus -2. 4 plus -2 would be 2. And then I divide that by 2 and I get 1. And I hope that makes sense, guys. Essentially, guys, think about it like this. Essentially, midline is just in between 4 and -2. Well, you can actually, because those numbers are pretty close, it's not even that hard to kind of just count to the middle. It's like, oh, I'm at -2, I'm at 4, and I count towards the middle. Well, if I go up 1 and down 1, I'm at 3 and -1. Repeat that. I'm at 2 and 0. Repeat that. I'm at 1 and 1. So it's like, oh, 1 is in the middle, right? So our midline for the first one is 1 meter. 1 meter. In the second one, I see most people seem to have gotten either 70 or 105. That's excellent. If you got either one of those, then you have the right idea, I think. Essentially, guys, looking at here, let's look at it from this perspective. Looking at it from the perspective of the word problem, I see that my maximum is 140. And my minimum is when it pushes out 70 milliliters. So that's 70 left. So my midline would be 140 plus 70 over 2, which would be 210 over 2, which would be 105, right? Alternatively, if you were looking at the graph here, guys, you can see that it goes between 140 and 0. So the midline of this graph is 70 milliliter. So kind of depending on which one you looked at, you would get a different answer. And that's once again because I low-key messed up my graph. Cool. Well, that's calculating that's figuring out midline of a model. That's figuring out amplitude and period of a model. So if you guys have found that today so far this makes sense, which I hope it does, then y'all should be doing pretty good on our way of understanding the connection between models of periodic behavior and kind of like the actual features and such, right? And what that allows us to do, guys, is essentially if I look at some word problem like this port UGAL problem, and I can figure out these different features like amplitude and period and midline and so on, then what we'll be able to do is create models with functions, right? We'll be able to create like sine functions, which actually model the tides. And then you could use that to make predictions and such. Cool. Well, if anyone has any questions for today, please stick around. Otherwise, you're free to go. Please say your goodbyes before you head on out. Bye-bye, guys. Bye-bye. Have a nice day. Hope you guys have a good third period. And I'm going to go ahead and turn off my screen share and stop the recording.